chapter 2.3. 2.3 is talking about how to create what is called a stem and leaf display. What it is an exploratory data analysis. I've given the page in your book that you can refer back to that. The main reason to use this is to rank things in order and arrange the data into groups. And this helps detect patterns, extreme data values. Extreme data values, whether they be small or extremely large, are called outliers. And it also allows us to recover the original data. Now, one of the keys to this is every value in your set of data is broken up into two parts. And I've given some numbers here. The one number is 123. So you have to take a 3-digit number and you need to break it up into 2 parts. So I've showed the different ways that you could do this. You could have the 1, which is on the far left, that would be called your stem, and then your leaf would be 23. Or a second way that you could divide that is to put the 1 and the 2 or 12 as your stem, and then 3 as your leaf. And they both represent the number 123. Then what you'll do, once you have decided how to divide your numbers, then you will arrange the stems in a vertical column up and down from the smallest to the largest. Then you will place all of your leaves, which I'll show you an example here in a little bit. And then you always need to be sure and label so you know what the numbers represent. Now, there's a really good example in your book. It's a guided exercise. It's talking about the points that are scored in basketball games. So if you'll look on page 65, guided exercise 4, you'll get a really good example. Then if you'll go to your book on page 67, question number 1, it's talking about the longevity of cowboys that lived in a particular time. And if you'll look at all the data values, when you are going to decide how to divide your digits up, you always want to find the smallest number and the largest number. Now in this case, they are both 2-digit numbers, so the only choice that we have is to divide it here. Now, once we do, then your far left values are known as the stem, so the 4 and the 9 would be the stem, and then the numbers on the right is known as the leaf. So these two 7s would be known as the leaf, okay? So then what I've done is I have created and I drew these 2 lines right here. Now over here will go the stem. So my smallest stem value is a 4. So then I would go by 1s, 4, 5, 6, 7, 8, 9 being the largest value. So I would stop. Now, here's how I found these values, which are your leaf. There was only one value that had a tens digit of 4, and that was 47. So I put the 7 here, so this 47 represents 47. Now, if you'll notice over here, what I did is I went through my set of data values and found all of the ones that were 50-something. So as I went through, I came across 58, 52, 58, and 57. So the 5 is my stem, which is located here. The 8, the 2, the 8, and the 7 are my leaf. But please notice when I put it in my stem and leaf, I put them in numerical from the smallest to the largest. Do not put 8, 2, 8, 7. Be sure you start with the smallest and go to the largest. Then if you'll notice here, I did the same thing for the 6s. So my stem is my 6, which is right here. And then my leaf is 6, 8, 8, 1, 6. I put those in numerical from smallest of 1 all the way up to the largest, which is 8. And then I went ahead and proceeded and did that for all of those that lived to be in their 70s and then lived to be in their 80s and then in their 90s. So that's how to create the stem and leaf. Now, once you have created that, it is extremely important that you label and give a scale so someone will know what those numbers represent. Because right now, if I looked at this and did not have the original problem, I wouldn't have no idea what these numbers represented. So when you're going to make the scale, choose any number in your set of data. I'm going to choose 72. Just because I chose 72, you might choose 68. It doesn't matter. So I have the 7 and the 2, and then I'm going to put equals, or I could write the word represents, and that represents 72 years old. So now that I have this scale of realizing that this represents 72 years old, I can come down here and go, oh, 85. Somebody lived to be 85 years old. Oh, 90. That would mean I lived to be 90 years old. So that's how you create a stem and leaf. Now, sometimes your data values may have a decimal. I've given an example here. We have the decimal 1.1. Suppose that was my smallest number, 1.1. Now notice I put a 0 in front of it because my largest number is 12.3. So when I'm dividing these, I need to have the same number of digits. Now, you could divide it here, or you could divide it here. So you typically look at your stem, and here you would just have a stem of 0 and 1, and then all the numbers in the leaf would go to the right. Well, that doesn't make a lot of sense. This is what makes more sense, because then you would have a stem of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then your leaf, you would then put the numbers, okay? So in this case, it does make sense to divide them at the decimal point. That will not always be the case. Suppose we had this number here. A lot of times it might make more sense to divide the numbers not necessarily where the decimal point is. So that's what makes this part where you define the scale so very important, because you will never, or you should never, see decimal points within the stem or the leaf. The decimal point will only be shown in the scale. So when I see 2294, if I don't have the scale, I would assume that's 2,294. But if someone had correctly labeled this, that 2294 is 229.4, then I would know my decimal point actually goes right here. So when I see 2317, I would know that that is 231.7. So that's just kind of an example of where you need to be careful with decimals. Then the last thing that I want to point out is sometimes what is called a changing scale is used in a stem and leaf. Notice my stem starts at 1 and it goes up to 17. Well, typically you would see it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. But if you do not have any leaf values that would fall from the 4 to the 15, there's no sense to write all of those numbers. So I have placed this squiggly line here. That way my eye is drawn there. This is what's called a changing scale, and I can look at that and go, oh, the numbers 4 through 15 are skipped because there weren't any data values there. That's chapter 2.3.